This video is on graphing quadratics in intercept form. We're going to graph in intercept form, identify characteristics, and write the equations in intercept form. So, previously, we've only graphed quadratics in this idea of vertex form. Vertex form meaning that we see the HK, the vertex of our quadratic. That tells us how far left and right, up and down we have to move the center of our graph, the vertex. A value meaning stretch, compression, or normal. Plus or minus meaning there is no reflection or no reflection. And we graphed it in terms of the standard quadratic pattern, which is we're squaring our x values. So we go left and right 1, and then we go up 1 y value. Left and right 2, up 4 y values. Left and right 3, up 9 values. And any manipulations that may occur after that in terms of the a value. So intercept form shares some of the same characteristics in that our plus and minus in front of our equation still means no reflection or reflection opening down. And our a value, if it's greater than 1, is still a vertical stretch. Our a value, if it's between 0 and 1, is still a vertical compression. And a is equal to 1 is still a standard. So that notation that we've been using is still consistent. What's different is this portion where we have x minus m and x minus n. In vertex form, we only had x minus h in parentheses, and we listed it as the opposite of the x value, where a positive actually moved us to the left or negative, and a negative actually moved us to the right or positive. What we see happening is if we take this idea, we would actually apply it to both of these two sets of parentheses. And instead of interpreting it as the horizontal movement of the vertex, we instead are going to interpret m and n as x-intercepts of our graph. So, intercept form, the name meaning that we are given the two x-intercepts of our graph. Now, could be one x-intercept if it's the same value, but we are given the x-intercepts of our graph, hence the name intercept form. A positive m value means we actually have a negative x-intercept. A negative m means that we have a positive intercept. And the same thing with n. A positive actually means it's a negative value. A negative value means it's a positive. It's the opposite of what we actually see. Okay, now, how is this helpful? Well, getting the x-intercepts of the graph is actually useful in terms of plotting it, but it's not actually the most efficient way to get the graph. What do I mean by that? Well, getting the two x-intercepts gives us 2 points on our graph. However, really, if we think about it, we liked graphing in vertex form. Graphing in vertex form is really, really nice. It gives us our HK, which is the center of the graph, and then I can use that a value to get the rest of the way. So, instead of trying to focus so much on graphing purely from intercept form, what we're going to do is we're going to utilize intercept form, a pattern that we see from intercept form, and actually turn it into vertex form to graph. Say it again. We like graphing in vertex form, so let's actually turn intercept form or use the values that we're given to actually make it look like vertex form, in that I want to actually figure out what the h and k are, and then if I have the vertex, we can just use our a value and graph normally. So as you see here, here is how our pattern of the values of given of m and n relate to finding the values of h and k. So to find the value of h, to find the h value of my vertex, all we are going to do is we are going to take and add our two given m and n values together and divide by 2. Now, this is just finding the average, or finding the middle of these two x-intercepts. And I want to show you where this formula came from. We're going to look at 2 graphs of quadratics and in relation. So here we could see that I could identify my x-intercepts on both of these graphs. I can identify my x-intercepts on both these graphs. And if I was just given those, how do I figure out where the center of my graph is going to be? Well, the vertex lies on the axis of symmetry, which goes through the center of the graph. Well, if you notice the distance between these two x-intercepts, they're side by side, and basically they're the same distance away. This is a distance of 1 away. Here I could count over and say this is a distance of 3, and this is a distance of 3 from the center of the graph. So if I didn't know what the h value was originally, all I need to do is walk to the middle, which essentially our formula does as well. So if I took -4 plus -2 and divided it by 2, that gives me -6 over 2, which is -3. Hey, that's where the h value of my vertex was. Same thing here. If I didn't actually know what it was, I could walk my way to the center and know it's at 2. Or if I take my x-intercepts here of -1 plus 5 and divide it by 2. That gives me 4 over 2, which is 2. Hey, that's the value that we had just listed there. Okay, so this formula is a way for us to go ahead and figure out the middle of the graph. You can also get it by just simply counting. So let's take a moment and actually practice finding the h value on the top of the previous page. So here are my two examples. I'm given two equations written in vertex form. Intercept form. So we could go ahead and identify m and n first. In our first value here, we see that I have to think about it as the opposite. So my m value is -2 and my n value is +4. In this other example, we see m is equal to +1 and n is equal to -5. Now, to find the h value, all we're going to do is take the average, which we see is -2 plus 4 over 2, which is 2 over 2, which is 1. Here we see 1 plus -5 over 2, or -4 over 2 equals -2. Now, to find the k value, all we are going to do is we are going to substitute in the h value into our equation for x. Essentially, this h value is just the x coordinate of our vertex. The k is just the y value of our vertex. So if we just found an x, we know from Algebra 1 the way to find a y is to simply substitute it in and simplify. So coming back up here, we're going to go ahead and substitute in our h value into each equation. So 1 plus 2 times 1 minus 4, and the -2 for the a value, -2 minus 1 times -2 plus 5. Simplifying gives us k is -9 in example D, and k is equal to 18 in example E. So putting these two things together, we get our vertex at 1, -9 for example D, and vertex at -2, 18 for example E. Well, let's actually go ahead and apply that now to doing some graphing. Looking down here at examples A, B, and C, we want to go ahead and graph each of these to its fullest. So we're going to start off with example A and example B. We will go ahead and, I'm actually going to change this to be just -1 instead of -3 in example B. Let's go ahead and identify A, M, and N in each of A value of 1, M of +1, it's the opposite, -3 the opposite, and then A is -1 in example B, and +1 and +3. So we're going to go ahead and graph these M and N values on our grid, as again, these are the x-intercepts of our graph, hence the name intercept form. Now what we're going to do is we just need to figure out what h and k is going to be so that we can go ahead and fill out the rest of the graph. Now, looking at these two examples, if I asked you where the middle of these two intercepts would be, we could probably count our way in to say that it's at -1 in example A and +2 in example B. Let's see the math to make sure. As we see, there it is. So to find our k value, all we're going to do is substitute these values into our original equation and simplify. Here giving us k equals -4 and k equals +1. Putting this hk together, we can graphing the vertex and filling in the graph, we have our quadratic. Now, we could add additional points if we'd like. An easy one to find would be the y-intercept, would be letting x equal to 0 into the equation, and then finding it in example A, it ends up being -3, and the same in B, it ends up being -3 as well. Don't need to have these other points, but if we're looking to be a more accurate graph, that doesn't hurt. Let's take a look at example C. Just because there's a fractional a value in front doesn't change it. The only thing that's going to matter is maybe our k value, the math may look a little bit awkward. So let's go ahead and take a look at this real quick. So here is all the math on this. Graphing our intercepts of 5 and -1, we find h is equal to +2. Plugging in to find k, we get our k value here, it's at 4.5. So that 1/2 in front made us half of 9 is 4.5, making us have to graph our vertex in a little half space. All we need to do now is just fill in the rest of the graph, and we have our quadratic. Why don't you go ahead and take a look at examples F, G, and H. We can ignore the information on the bottom here. Why don't you go ahead and take a moment and see if you can graph those. And here are our graphs for examples F, G, and H. Notice again the math for H in each of these matches up with what we would get if we would simply count to the middle. Whether you do the math or whether you count is up to you. Evaluating for K, though, we need to see gives us our vertex, and we get our answers. Now, something of note before we start writing equations is that the A value in each of these graphs is actually still very clearly seen in the pattern. So notice here, if I go over 1, we're actually going down 2, which in this case matches our A value. Here, if I go over 2, we're only going up 2. Normally what happens is we go up 4, so this is half of the movement, which again matches up with our a value of half. Here I go over 1 and I go up 3, which again normally we go over 1 and up 1. That's times 3 the movement. So the a value is still very clearly seen, and we can clearly see the x-intercepts. So looking down here to try to write the equations, if we're writing it in intercept form, all we need to do is list the intercepts and then calculate our a like we had done yesterday. So in example I, we see that m is equal to -1 and n is equal to 5. So meaning in terms of intercept form, we would write this as x plus 1 and x minus 5. Again, the opposite values of what we see. Now, looking to figure out our a value, we see that we go over 1 and down 1. Normally we go over 1 and up 1, so that must mean our a value is -1. Take a moment and see if you can try j and k. Here are our answers for j and k, a value of 1/2 in j and -2 in k. Again, key parts for intercept form being that we are given our two x-intercepts listed as the opposite of what we see. In terms of graphing, we're going to plot them and then work backwards to figure out our hk value from the which was like our vertex form, which is way nicer to graph.